In ancient times, only the Sun and Moon, a few hundred stars and the most easily visible planets had names. Over the last few hundred years, the number of identified astronomical objects has risen from hundreds to over a billion, and more are discovered every year. Astronomers need to be able to assign systematic designations to unambiguously identify all of these objects, and at the same time give names to the most interesting objects and, where relevant, features of those objects. The International Astronomical Union is the officially recognized authority in astronomy for assigning designations to celestial bodies such as stars, planets, and minor planets, including any surface features on them. In response to the need for unambiguous names for astronomical objects, it has created a number of systematic naming systems for objects of various sorts. Stars. There are no more than a few thousand stars that appear sufficiently bright in Earth's sky to be visible to the naked eye. This represents the number of stars available to be named by ancient cultures. The upper boundary to what is physiologically possible to be seen with the unaided eye is an apparent magnitude of 6, or about 10,000 stars. With the advent of the increased light-gathering abilities of the telescope, many more stars became visible, far too many to all be given names. The earliest naming system which is still popular is the Bayer designation, using the name of constellations to identify the stars within them. The IAU is the only internationally recognized authority for assigning astronomical designations to celestial objects and surface features on them. The purpose of this is to ensure that names assigned are unambiguous. There have been many historical star catalogues, and new star catalogues are set up on a regular basis as new sky surveys are performed. All designations of objects in recent star catalogues start with an initialism, which is kept globally unique by the IAU. Different star catalogues then have different naming conventions for what goes after the initialism, but modern catalogues tend to follow a set of generic rules for the data formats used. The IAU does not recognize the commercial practice of selling fictitious star names by commercial star naming companies. The IAU's website uses the word charlatanry in this context. Proper names. There are about 300 to 350 stars with traditional ahistorical proper names in common usage. They tend to be the brightest stars in the sky and are often the most prominent ones of the constellation. Examples are Betelgeuse, Rigel and Vega. Most such names are derived from the Arabic language. Stars may have multiple proper names, as many different cultures named them independently. Polaris, for example, has also been known by the names Ulrika, Angel Stern, Cynosure, the Lodestar, Mesmar, Navigatoria, Venus, the Pole Star, the Star of Arcady, Tramontana and Yield, as at various times and places by different cultures in human history. In 2016, the IAU organized a working group on star names to catalog and standardize proper names for stars. The WGSN's first bulletin of July 2016 included a table of the first 2 batches of names approved by the WGSN together with names of stars adopted by the IAU Executive Committee Working Group on Public Naming of Planets and Planetary Satellites during the 2015 Name Exo Worlds campaign, and recognized by the WGSN. These names are incorporated in the IAU Catalogue of Star Names. The star nearest to Earth is typically referred to simply as the Sun, or its equivalent in the language being used. However, it is sometimes called by its Latin name, Sol, in science fiction. Named after people, there are about 24 stars such as Barnard's star and Captain's star that have historic names and which were named in honor after astronomers. As a result of the Name ExoWorlds campaign in December 2015, the IU approved the names Cervantes and Copernicus for the stars Mu Array and 55 Cancri A, respectively. In July 2016, the IUWGSN approved the name Cor Caroli for the star Alpha Canum Venaticorum, so named in honor of King Charles I of England by Sir Charles Scarborough, his physician. Catalogues with the advent of the increased light-gathering abilities of the telescope, many more stars became visible, far too many to all be given names. Instead, they have designations assigned to them by a variety of different star catalogues. Older catalogues either assigned an arbitrary number to each object, or used a simple systematic naming scheme based on the constellation the star lies in. The variety of used sky catalogues means that now most bright stars have multiple designations. By designation, the Bayer designations of about 1,500 brightest stars were first published in 1603. In this list, a star is identified by a lowercase letter of the Greek alphabet followed by the Latin name of its parent constellation. The Bayer designation uses the possessive form of a constellation's name, which mostly ends in re, e, as an A. In addition, a three-letter abbreviation is often used. Examples include Alpha Andromedae in the constellation of Andromeda, Alpha Centauri in the constellation Centaurus, Alpha Crucis and Beta Crucis, the two brightest stars in the constellation Crux, the Southern Cross, Epsilon Carinae and Carina, Lambda Scorpii in Scorpius and Sigma Sagittarii in Sagittarius. After all 24 Greek letters have been assigned, upper and lower case Latin letters are used, such as for A Centauri, D Centauri, G Scorpii, P Cygni, B Sagittarii, D Centauri and S Carinae. As the resolving power of telescopes increased, numerous objects that were thought to be a single object were found to be optical star systems that were too closely spaced in the sky to be discriminated by the human eye. This led to a third iteration, where numeric superscripts were added to distinguish those previously unresolved stars. Examples include Theta Sagittarii, later distinguished as Theta Sagittarii and Theta squared Sagittarii, each being their own star system with 2 and 3 stars, respectively. Flamsteed designation. Flamsteed designations consist of a number and the Latin genitive of the constellation the star lies in. Examples include 51 Pegasi and 61 Cygni. About 2,500 stars are catalogued. They are commonly used when no Bayer designation exists, or when the Bayer designation uses numeric superscripts such as in Rho Cancri. In this case, the simpler Flamsteed designation, 55 Cancri, is often preferred. Modern catalogues. Most modern catalogues are generated by computers, using high-resolution, high-sensitivity telescopes, and as a result describe very large numbers of objects. For example, the Guide Star Catalog 2 has entries on over 998 million distinct astronomical objects. Objects in these catalogues are typically located with very high resolution, and assign designations to these objects based on the position in the sky. An example of such a designation is SDSSP J15325996003944.1, where the initialism SDSSP indicates that the designation is from the Sloan Digital Sky Survey preliminary objects, and the other characters indicate celestial coordinates. Compact stars, pulsars, black holes. Black holes have no consistent naming conventions. Supermassive black holes receive the designation of the galaxy in which core they reside in. Examples are NGC 4261, NGC 4151, and M31, which derive the designation from the New General Catalogue and the list of Messier objects. Other black holes, such as Cygnus X1, a highly likely stellar black hole, are catalogued by the constellation and the order in which they were discovered. A large number of black holes are designated by the position in the sky and prefixed with the instrument or survey that discovered them. Examples are SDSSJ0100 plus 2802 and RxJ1131 minus 1231, observed by the Chandra X-ray Observatory. Supernova discoveries are reported to the IAU's Central Bureau for Astronomical Telegrams and are automatically given a provisional designation based on the coordinates of the discovery. Historically, when supernovae are identified as belonging to a type, CB80 has also published circulars with assigned year-letter designations and discovery details. A supernova's permanent designation is formed by the standard prefix SN, the year of discovery, and a suffix composed of one or two letters of the Latin alphabet. The first 26 supernovae of the year receive a capital letter from A to Z. Subsequent supernovae of that year are designated with pairs of lowercase letters from AA to Arizona, and then continuing with bar until ZZ. For example, the prominent SN1987A was the first one to be observed in 1987. Several thousand supernovae have been reported since 1885. In recent years, several supernova discovery projects have retained the more distant supernova discoveries for in-house follow-up, and not reported them to CB80. Starting in 2015, CB80 has scaled back its efforts to publish assigned designations of typed supernovae. By September 2014, CB80 had published names and details of 100 supernovae discovered in that year. By September 2015, CB80 had only published names of 20 supernovae discovered in that year. The Astronomer's Telegram provides some surrogate services independent from CB80. 4 historical supernovae are known simply by the year they occurred: SN 1006, SN 1054, SN 1572, and SN 1604. Since 1885, the letter suffixes are explicitly assigned, regardless whether only one supernova is detected during the entire year. Driven by advances in technology and increases in observation time, there are hundreds of supernovae being reported every year to the IAU, with more than 500 reported in the record year of 2007. Since then, the number of annually reported supernovae has declined steadily. Novi Constellations. The sky was divided into constellations by historic astronomers, according to perceived patterns in the sky. At first, only the shapes of the patterns were defined, and the names and numbers of constellations varied from one star map to another. Despite being scientifically meaningless, they do provide useful reference points in the sky for human beings, including astronomers. In 1930, the boundaries of these constellations were fixed by Eugene Joseph Delport and adopted by the IAU, so that now every point on the celestial sphere belongs to a particular constellation. Galaxies. Like stars, most galaxies do not have names. There are a few exceptions, such as the Andromeda Galaxy, the Whirlpool Galaxy, and others, but most simply have a catalogue number. In the 19th century, the exact nature of galaxies was not yet understood, and the early catalogues simply grouped together open clusters, globular clusters, nebulas, and galaxies. The Messier catalogue has 110 in total. The Andromeda Galaxy is Messier Object 31, or M31. The Whirlpool Galaxy is M51. The new general catalogue was much larger and contained nearly 8,000 objects, still mixing galaxies with nebulas and star clusters. Planets. The brightest planets in the sky have been named from ancient times. The scientific names are taken from the names given by the Romans: Mercury, Venus, Mars, Jupiter, and Saturn. Our own planet is usually named in English as Earth, or the equivalent in the language being spoken. However, it is only recently in human history that it has been thought of as a planet. Earth, when viewed as a planet, is sometimes also called by its Latin scientific conventional name Terra. The Latin convention derives from the use of that language as an international scientific language by the first modern astronomers like Copernicus, Kepler, Galileo, Newton and others, and was used for a long time. This is why the later discovered bodies were also named accordingly. At least two more bodies were discovered later and called planets: Uranus, discovered by William Herschel in 1781, Neptune, discovered by Johann Gottfried Galle in 1846. These were given names from Greek or Roman myth, to match the ancient planet names, but only after some controversy. For example, Sir William Herschel discovered Uranus in 1781, and originally called it Georgium Sidus in honor of King George III of the United Kingdom. French astronomers began calling it Herschel before German Johann Bode proposed the name Uranus after the Greek god. The name Uranus did not come into common usage until around 1850. Starting in 1801, asteroids were discovered between Mars and Jupiter. The first few were initially considered planets. As more and more were discovered, they were soon stripped of the planetary status. On the other hand, Pluto was considered to be a planet at the time of its discovery in 1930, as it was found beyond Neptune. Following this pattern, several hypothetical bodies were given names: Vulcan for a planet within the orbit of Mercury, Phaeton for a planet between Mars and Jupiter that was believed to be the precursor of the asteroids, Themis for a moon of Saturn and Persephone, and several other names for a trans-Plutonian planet. Derived from classical mythology, these names are only considered standard in Western discussion of the planets. Astronomers in societies that have other traditional names for the planets may use those names in scientific discourse. The IU does not disapprove of astronomers discussing Jupiter in Arabic using the term al-Mushtari. Some 60 years after the discovery of Pluto, a large number of large trans-Neptunian objects began to be discovered. Under the criteria of classifying these Kuiper belt objects, it became dubious whether Pluto would have been considered a planet had it been discovered in the 1990s. Its mass is now known to be much smaller than once thought, and with the discovery of Eris, it is simply one of the two largest known trans-Neptunian objects. In 2006, Pluto was therefore reclassified into a different class of astronomical bodies known as dwarf planets, along with Eris and others. Exoplanets. Currently, according to the IU, there is no agreed system for designating exoplanets. The process of naming them is organized by the IAU Executive Committee Working Group Public Naming of Planets and Planetary Satellites. The scientific nomenclature for the designations usually consists of a proper noun or abbreviation that often corresponds to the star's name, followed by a lowercase letter, like 51 Pegasi b. The lowercase lettering style is drawn from the IAU's long-established rules for naming binary and multiple star systems. A primary star, which is brighter and typically bigger than its companion stars, is designated by capitalized A. Its companions are labeled B, C, and so on. For example, Sirius, the brightest star in the sky, is actually a double star, consisting of the naked eye Sirius A and its dim white dwarf companion Sirius B. The first exoplanet tentatively identified around the second brightest star in the triple star system Alpha Centauri is accordingly called Alpha Centauri BB. If an exoplanet orbits both of the stars in a binary system, its name can be, for example, Kepler 34b. Natural satellites. Earth's natural satellite is simply known as the Moon, or the equivalent in the language being spoken. It is sometimes called lunar in science fiction. Natural satellites of other planets are generally named after mythological figures. Satellites of Uranus are named after characters from works by William Shakespeare or Alexander Poe. When natural satellites are first discovered, they are given provisional designations such as S2010J2 or S2003S1. The initial S stands for satellite and distinguishes from such prefixes as D, C, and P used for comets. The designation R is used for planetary rings. These designations are sometimes written like S2003S1, dropping the second space. The letter following the category and year identifies the planet. Pluto was designated by P prior to its recategorization as a dwarf planet. When the object is found around a minor planet, the identifier used is the latter's number in parentheses. Thus, Dactyl, the moon of 243 Ida, was at first designated S1993-1. Once confirmed and named, it became Ida-Dactyl. Similarly, the fourth satellite of Pluto, Kerberos, discovered after Pluto was categorized as a dwarf planet and assigned a minor planet number, was designated S2011-1 rather than S2011P1, though the New Horizons team, who disagreed with the dwarf planet classification, used the latter. H equals Mercury, V equals Venus, E equals Earth, M equals Mars, J equals Jupiter, S equals Saturn, U equals Uranus, N equals Neptune. Note: the assignation of H for Mercury is specified by the USGS Gazetteer of Planetary Nomenclature, since they usually follow IU guidelines closely. This is very likely the IU convention, but confirmation is needed. After a few months or years, when a newly discovered satellite's existence has been confirmed and its orbit computed, a permanent name is chosen, which replaces the S provisional designation. However, in the past, some satellites remained unnamed for surprisingly long periods after the discovery. See naming of moons for a history of how some of the major satellites got their current names. The Roman numbering system arose with the very first discovery of natural satellites other than Earth's. Galileo referred to the Galilean moons as I through IV, in part to spite his rival Simon Marius, who had proposed the names now adopted, after his own proposal to name the bodies after members of the Medici family failed to win currency. Similar numbering schemes naturally arose with the discovery of moons around Saturn and Mars. Although the numbers initially designated the moons in orbital sequence, new discoveries soon failed to conform with this scheme. The unstated convention then became, at the close of the 19th century, that the numbers more or less reflected the order of discovery, except for prior historical exceptions. Geological and geographical features. In addition to naming planets and satellites themselves, the individual geological and geographical features such as craters, mountains, and volcanoes on those planets and satellites also need to be named. In the early days, only a very limited number of features could be seen on other solar system bodies other than the Moon. Craters on the Moon could be observed with even some of the earliest telescopes, and 19th-century telescopes could make out some features on Mars. Jupiter had its famous Great Red Spot also visible, though early telescopes. In 1919 the IU was formed, and it appointed a committee to regularize the chaotic lunar and Martian nomenclatures then current. Much of the work was done by Mary Adela Blagg, and the report named Lunar Formations by Blagg and Muller was the first systematic listing of lunar nomenclature. Later, the system of lunar craters, quadrants I, II, III, IV, was published under the direction of Gerard P. Kuiper. These works were adopted by the IAU and became the recognized sources for lunar nomenclature. The Martian nomenclature was clarified in 1958, when a committee of the IAU recommended for adoption the names of 128 albedo features observed through ground-based telescopes. These names were based on a system of nomenclature developed in the late 19th century by the Italian astronomer Giovanni V. Schiaparelli and expanded in the early 20th century by Eugene M. Antoniadi, a Greek-born astronomer working at Meudon, France. However, the age of space probes brought high-resolution images of various solar system bodies, and it became necessary to propose naming standards for the features seen on them. Minor planets. Initially, the names given to minor planets followed the same pattern as the other planets. Names from Greek or Roman myths, with a preference for female names. With the discovery in 1898 of the first body found to cross the orbit of Mars, a different choice was deemed appropriate, and 433 Eros was chosen. This started a pattern of female names for main belt bodies and male names for those with unusual orbits. As more and more discoveries were made over the years, this system was eventually recognized as being inadequate and a new one was devised. Currently, the main responsibility for designating and naming minor planets lies with the Committee for Small Body Nomenclature, which is composed of 15 people. When observed at least 2 nights and cannot be identified with an existing celestial object, minor planets are initially assigned provisional designations of the form 2001 KX76. If enough sightings are obtained of the same minor planet to calculate an orbit, the object is assigned a sequential number, its designation, and it can then be cited as, for instance, 2001 KX76. After the designation is assigned, the discoverer is given an opportunity to propose a name, which, if accepted by the IAU, replaces the provisional designation. This will happen after an observation interval of 2 to 3 months. Thus, for instance, 2001 KX76 was given the name Ixion and is now called 28978 Ixion. The name becomes official after its publication in the Minor Planet Circular with a brief citation explaining its significance. This may be a few years after the initial sighting, or in the case of lost asteroids, it may take several decades before they are spotted again and finally assigned a designation. If a minor planet remains unnamed 10 years after it has been given a designation, the right to name it is given also to identifiers of the various apparitions of the object, to discoverers at apparitions other than the official one, to those whose observations contributed extensively to the orbit determination, or to representatives of the observatory at which the official discovery was made. The CSBN has the right to act on its own in naming a minor planet, which often happens when the number assigned to the body is an integral number of thousands. In recent years, automated search efforts such as Linear or LONDOS have discovered so many thousands of new asteroids that the CSBN has officially limited naming to A maximum of 2 names per discoverer every 2 months. Thus, the overwhelming majority of asteroids currently discovered are not assigned formal names. Under IAU rules, names must be pronounceable, preferably one word, although exceptions are possible, and since 1982, names are limited to a maximum of 16 characters, including spaces and hyphens. Letters with diacritics are accepted, although in English the diacritical marks are usually omitted in everyday usage. 4090 Resavetst is an asteroid with the most diacritics. Military and political leaders are unsuitable unless they have been dead for at least 100 years. Names of pet animals are discouraged, but there are some from the past. Names of people, companies or products known only for success in business are not accepted, as well as citations that resemble advertising. Whimsical names can be used for relatively ordinary asteroids, but those belonging to certain dynamical groups are expected to follow more strictly defined naming schemes. Jupiter Trojans are named for characters of the semi-mythical Trojan War. Asteroids at Lagrangian point L4 are named after Greek characters, whilst asteroids at L5 are named after Trojans. Transjovian minor planets crossing or approaching the orbit of a giant planet but not in a stabilizing resonance are named for centaurs. Objects in Neptune's 3:2 mean motion resonance are named after mythological creatures associated with the underworld. Classical Kuiper belt objects are given mythological names associated with creation. Objects that approach across Earth's orbit are still given mythological names, preferably male.